Hello and welcome to C++ programming. I will talk about a new smart pointers technology that is with us since C++11 standard. I will focus on shared pointer, which is one of the smart pointers. We don't know how much memory we need at compile time, therefore we have to use dynamic memory allocation and heap. If you program in C or C++, you'll probably use malloc or new operator to allocate more memory. Programs that do some serious work will use significant amount of memory, and sooner or later you will run out of it, so you should use free or delete to free some memory so you can use it later, but most of the time you will forget to do that and you will have a memory leak, and at some point you will run out of memory on your computer and you will see a message like this. At this point, program might crash or even the entire system may crash. So you will start debugging process, and optimistically maybe 3 hours later you will find your memory leak, which in this case was somewhere over here. Memory leaks are annoying, but can you do something about it if you program in C++? Is new indeed the only way to allocate more memory? And the answer is no. You can use smart pointers. There are 3 smart pointers in C++11 standard. We have shared pointer, unique pointer, and weak pointer. In the old standard we had auto-ptr, but you shouldn't use it anymore, it's deprecated. This is my program that will demonstrate the usage of shared pointers. So it's pretty simple, but it gets the job done. So what I have over here is I have a function, the biggest number, that will randomly pick some numbers and return the biggest one it picked. So inside I have a for loop. I ask the user over here how many iterations I want to make, and then inside of this function I have a for loop. So for this many iterations I will create an object. An object in a constructor will pick a random number. I have some max number so far. If the object I created has a bigger number than our current max, I will store it, and at the end I will return the value. I have some global values to keep track of the memory. Maximum number of memory I allowed myself to allocate is about 2 gigabytes. This variable will store how many bytes I allocated so far. I have another one to count how many objects I constructed, and another one for how many objects I destroyed. And in a constructor I will simply increment number of bits in use. I will increment number of object constructor. In destructor I will do the opposite. I mean, I will increment number of destroyed object, and I will decrement use of memory. Okay, and if there is no more memory, if memory in use exceeds maximum amount of memory I allow myself to allocate, then I will throw exception. So let's run it. Okay, so how many iterations I want? I want 3 million iterations. Oh, I got no more memory error message. It says right here that I'm using about 2 gigabytes of memory, which is everything I allowed myself to use. And I constructed about 2 million objects, which is less than I asked for, because I asked for 3 million. Yeah, so it's happening because I don't delete any objects. So over here, if the newly created object has a bigger value than my maximum so far, I store it, and else I want to delete it because I don't need it anymore. Delete PTR. Okay, let's run it and let's see how it goes. Okay, I constructed 3 million, so I constructed all of them, but I didn't destroy all of them for some reason. And the reason is that when I do this assignment over here, I don't free this max before I assign. I don't free this max over here before I assign PTR to it. So let's free it. Let's delete max and let's run again. Okay, 3 million again. Okay, notice that we have one more object to delete because we constructed 3,000,001 and we destroyed 3 million. It's because of this max over here. So we cannot return value like this. We have to store the value then we have to delete max and then we return the value. Okay, and now if I run it, I can type in 5 million. Now it works fine. I have memory in use 0. It means that I deleted everything. Okay, but you see how many cases I had to cover. I have to delete over here, and over here. So let's not do this. Let's use shared pointers, which is the other function, which is right here. Syntax for shared pointer is this, which is shared pointer type of the object it points to, and since this is stack object, I call it its constructor like this. So this is how I point shared pointer to heap object, and so this is my max. In my for loop, I create another shared pointer. So this is a random number I create every iteration, and I check if it's bigger than our current max, and I store it, and I don't do anything else, and I return the value at the end. So what happens when I run it? Let's say 8 million. Okay, and several hours later, I have memory in use 0. Object constructed equals object destroyed. Means that we have no memory leaks, so shared pointers in fact work. So how does it work? So every time you create a new object using shared pointer, it will create a manager that keeps the reference count of shared pointers to that object. So initially I have only one shared pointer, so shared count is 1. During the execution I can assign more shared pointers to the same object, so now I have 2, shared count is 2. So now pointer 1 fell out of the scope, so shared count was decremented by 1 because stack object pointer 1 called its own destructor when it fell out of the scope. And now the same thing will happen with pointer 2. It decremented the shared count by 1. Shared count is now 0. So this manager will delete object. So we don't have to do anything. C++ will delete all unnecessary objects. Smart pointers will improve your productivity, and they are now part of the standard, so they strongly recommended over raw pointers, which are very insecure because of memory leaks. So goodbye memory leaks, and thanks for listening.